Now we list the sines of angles theta from 0 to pi over 2 and beyond. Now from 0 to pi over 2 we get the familiar angles. Let's move over a little bit so we can see this figure part of it. We'll take a closer look in a minute. But as we go past pi over 2, so we've got the angles 0, pi over 6, pi over 3, pi over 2. We hit 2 pi over 3. Now 2 pi over 3 is just symmetric about the y-axis with pi over 3. So that the sine is the same. The y-coordinate is still 0.87. This circle implicitly has a radius of 1, so that we see that we have a y-coordinate of 0.87 at this point or at this point. Similarly at 5 pi over 6, y equals 0.5, just as it does at pi over 6. At 7 pi over 6 or 11 pi over 6, we have y equals negative 0.85, just symmetric with respect to the x-axis here with the pi over 6 and 5 pi over 6. And similarly, down here we have y equals negative 0.87, y equals negative 1. So we can easily construct this table using these values. We come up to 1, and then we come down to 0.87, 0.5, and 0, here, here, and here at these angles. Then we go into the negative 0.5, negative 0.87, and so forth. And we go all the way around the circle. Now let's go ahead and just zoom in briefly in this circle in case you want to take a close look at some of those values. We can construct a good graph of the sine function between 0 and 2 pi, where we've labeled pi over 2 pi and 3 pi over 2. If we break each of these 4 intervals here into 3 subintervals for pi over 6, pi over 3, and then pi over 2, then 2 pi over 3, 5 pi over 6, pi, and so forth. Every pi over 6 units we're going to draw a vertical dotted line. And then we're going to draw horizontal lines for y equals 0.5, which of course corresponds to the sine of pi over 6, to y equals 0.87 corresponding to the sine of pi over 3, and of course y equals 1 corresponding to the sine of pi over 2. And we're going to continue in this manner, and we're going to plot the points at the corner of each rectangle successively, and we're going to move through the cycle of the sine function. One comment we can see is that these lines are not equally spaced. The horizontal lines are not equally spaced. We have a bigger rise from here to here than we do from here to here or from here to here. So we see how the slope decreases as we approach the maximum value of the sine, and then its magnitude begins to increase until we get down to here, and then the magnitude of the slope decreases, and so forth.